In this video, we're going to get the Taylor series expansion for ln x. So we know that 1 over 1 minus z will be the sum from n equals 0 to infinity of z to the n. So if we want 1 over x, this will be 1 over 1 minus, instead of z, we're going to write 1 minus x. So if you multiply this out, the negative out, you get 1 minus 1 plus x, so that's just x. So this will be the sum, n equals 0 to infinity. Instead of z, we're going to write 1 minus x to the n. So we know that natural log of x is the integral of 1 over x dx, which is equal to the integral of the sum n equals 0 to infinity of 1 minus x to the n dx. We're going to exchange the integral and the sum, so we get the sum n equals 0 to infinity of the integral of 1 minus x to the n dx. We're going to use the power rule, so we're going to add 1 and divide by it. So we're going to get the sum n equals 0 to infinity of 1 minus x to the n plus 1 over n plus 1 divide by the derivative of the inside. The derivative of the inside is negative 1, so we're going to divide by negative 1, so it'll just be negative. And then we're going to add c, because any indefinite integral will have c. So we get that ln x is the sum from n equals 0 to infinity of negative 1 times 1 minus x, the n plus 1, over n plus 1, plus c. We can plug in x equals 1. The left-hand side, ln of 1 is 0. And then this will be 1 minus 1, so this will also be 0 for all terms, plus c. This means that c equals 0. So we had the ln x is the sum, n equals 0 to infinity of negative 1 minus x, the n plus 1 over n plus 1. And we can rewrite this a little bit, so we can have n going to 1, so we add 1 to n, so we have to subtract 1 from every other term, so this will be, so n going to n plus 1. This will be n plus 1 go to n over n. And the other step we can do is, so we can take a negative 1 out of this, so this will be negative 1 to the n times x minus 1 to the n. Well, this is negative 1 to the first power, so this will be the sum, n equals 1 to infinity, negative 1 to the n plus 1, or n minus 1, because it's the same thing, times x minus 1 to the n over n. And that is the value for ln x as a Taylor series. Additionally, we know that 1 over 1 minus x is the sum on the right-hand side, only when x is greater than negative 1, but less than 1. So if we make it 1 over 1 minus x, so this will be 1 over x, so this will be the sum n equals 0 to infinity of 1 minus x to the n. But this is only valid when the absolute value of 1 minus x is less than 1. So this would be 1 minus x is less than 1 is less than negative 1. So then minus 1 on both sides, you get negative 2 less than negative x is less than 0. Multiply by negative 1. So that will switch the order, so it will be 0 is less than x is less than 2. So we have that this natural log of x is this sum on the right-hand side, only when x is between 0 and 2. But now we have to check, because we integrated, we have to check when x equals 0, and we have to check when x equals 2. So I'll let you do that on your own, but when x equals 0, you get ln is 0, which is not even a number. So this will be less than 0, but at x equals 2, this actually does work. So you have that the natural log of x is this sum on the right-hand side only when x is less than or equal to 2 and x is greater than 0.